Good afternoon, folks. Seventh period, you are viewing this video for your notes today. So the substitute should have already collected your homework from yesterday, and I will grade that. So today we'll go ahead and go through. You can see this is still day 5. We're still talking about graphing quadratics, and we'll start with our warm-up here. Find the vertex, the equation of the axis of symmetry, and the y-intercept of each function without graphing. So you should not need to use the graphing calculator online. We should be able to do all of this without the use of that. So first up, let's find the vertex. Well, in number 1, that thing is in standard form. So if I'm going to find the vertex, my formula is negative b over 2a. My negative b will be negative 6 over 2 times negative 3. So basically, if you multiply the bottom, you get negative 6. So this will be negative 6 over negative 6, which comes out to be 1. And then you need to plug 1 back into the original function. Again, remember, I recommend that you put that in parentheses. And when you compute that, you should get 2. So there's your vertex, 1, 2. Remember, the axis of symmetry runs right through the vertex, and it is a vertical line. So the equation will be x equals 1. And finally, the directions ask for the y-intercept. Remember, for every y-intercept, the x is 0. So if my x is 0 and I put a 0 in up there, the only thing I would have left is the negative 1. Okay, moving on to number 2. Again, let's find that vertex. It's in standard form, so negative b over 2a. If you multiply the bottom, you get negative 2. And negative 2 over negative 2 is 1. Again, plug that 1 in, being sure to put the 1 in parentheses. And be careful with that negative symbol in front of the x squared. And we'll get 2. Again, your axis of symmetry runs right through the vertex, and it is vertical. And the y-intercept means all of the x's would be 0. So we'll get that. And last but not least, another standard form over here. So the vertex will be negative b over 2a. And if we multiply and reduce that, we'll get 2. Plug in that 2, and you should get 1. Axis of symmetry runs right through the vertex. And for the y-intercept, we are plugging in all of those x's to be 0, and you should get 5. All right, that's your warm-up for today. Okay, down for your notes, you can see we have this chart that we've had for the previous 4 days. So I'm going to go ahead and fill it in. I'm not going to do much talking. I'll just go ahead and fill that in since we've explained this in depth previously. So just go ahead and copy it through here. Okay, so there we've got all our information that we've been talking about repeatedly for about a week now. Okay, so let's take a look at our directions here. Consider the function, determine if it has a maximum or minimum, state the maximum or minimum value, and determine the domain and range. Now, we should be able to do this without any graphing, okay? First and foremost, you know that the max and min happens at the vertex. Okay, so for that, I'm going to need to find the vertex. Let's go ahead and do that. Will this thing have a max or a min? Well, the a out front on the squared term is positive. That means it will open like this, which means we will have a minimum value. Okay. Part B said, what is the minimum value? So there's where I'm going to need to find my vertex. Now, this is in standard form. So I'll do negative b over 2a, and when I do that, I should get negative 6. Now, to find that maximum or minimum value, you have to plug in that negative 6. Please be sure to put it in parentheses, and you should get negative 21. And that is the value we're looking for this answer. Finally, we need the domain and range. Okay, well, for the domain, that's horizontally. Remember, this U shape should get bigger and bigger and bigger going horizontally, okay? So that will be all real numbers. Now the range, remember this thing had a minimum point right here. So that's the lowest it will ever go. And remember, that's at this negative 21 number right here, okay? So the y will always be greater than or equal to negative 21. All right, number 2, let's do the same thing. First of all, I'm looking at that function, and the x squared is negative, which means it will open down, and therefore it has a maximum. Now we actually need to find that max, which means we need to find the vertex. Standard form tells me to do negative b over 2 times a, and that'll give me a negative 4. Now we need to plug in that negative 4 to actually see where the maximum occurs. And when you plug that in, of course, in parentheses, you get that your maximum value is 50. Okay, domain and range. As for all parabolas, the domain will keep getting wider and wider horizontally, so that means all real numbers. The range, this thing had a maximum right up here, and that was at 50. So the y's will always be less than or equal to 50. And number 3, looking at that, the x squared is positive, which means it opens up and it will have a minimum. If I want to find that minimum, I need to find the vertex, negative b over 2a. And when you do that, you should get negative 5. Be careful plugging in that negative 5, folks, and you should get negative 56. That is your minimum value. All right, now the domain. All real numbers, because that U shape is going to get wider and wider. The range, this thing had a minimum. That's the lowest it will go right there. Okay, so the y's will always be greater than or equal to negative 56. All right, let's do some word problems on the back here. It says the cheerleaders at North High School launch t-shirts into the crowd every time the Truckers score a touchdown. The height of the t-shirts can be modeled by the function h of x equals negative 16x squared plus 48x plus 6, where h of x represents the height of the t-shirts in feet after x seconds. what is the maximum height the t-shirts will reach? So how high will they go? That means this will be happening at the vertex. So we need to find the vertex. It is in standard form, so we're going to do negative b over 2 times a, and that will give us 1.5. Plugging in that 1.5 will give me 42. That means the maximum these t-shirts will go is 42 feet up into the air. How long before the t-shirts reach their maximum height? Well, how long? That's the amount of time. If you look back in this problem, it says x is representing seconds, and seconds is an amount of time. So the maximum occurs at the vertex. So I need the x coordinate of the vertex. So this will happen at 1.5 seconds. So those t-shirts at 1.5 seconds are as high as they are ever going to go. All right, and finally, what is the height where the t-shirt was launched? That means what height did they start at? Well, when we talk about starting points, normally with a line, we talk about the y-intercept. That's always where you started on the graph. So we're going to find the y-intercept, and that's going to tell me where these t-shirts were launched from. Remember, for y-intercepts, that means the x's are 0. If you plug in 0 into the original function, you will get 6, which means the cheerleaders are launching these t-shirts from 6 feet off the ground. All right. Number 2, the marching band is selling poinsettias to buy new uniforms. Last year, the band charged $5 each, and they sold 150 of them. They want to increase the price this year, and they expect to lose $10 in sales. Lose 10 sales for every dollar increase. The revenue, R, in dollars generated by the sales can be modeled by the equation, you see it there, where P is the number of $1 increases in price. Ooh, that's a lot of information. Okay, letter A, write it in standard form. Well, my function is over here, R equals. That is a binomial times a binomial. So we're going to go ahead and distribute that, and we're going to write it in standard form. So 5 times 150 is 750. 5 times negative 10p is negative 50p. P times 150 is 150p. And p times negative 10p is negative 10p squared. So if I actually put my like terms together and I write it in the correct order, we're going to put our squared term first, put those regular p's together, and you should get 100. And then we have our constant on the end, which is 750. So there's my standard form. All right, find the maximum value. Well, that, of course, happens at the vertex. So let's do our negative b over 2a, and it looks like that. This should give you 5. And then plugging in that 5 should give you 1,000. So the maximum value is 1,000. The question is 1,000 what? Well, this is telling me the dollars generated by sales. So they will generate $1,000 as their maximum. How much revenue will be brought in by increasing the price by $3? Okay, now remember, we're doing $1 increases. If I'm going up by $3, that is 3 $1 increases. So I am going to have to plug in 3 into the original function or into my standard form. So either here or here, we're going to plug in that 3. And you should get $960. And you notice that's less than our maximum, which it should be because that 1,000 should have been the highest it should go. Now it says, how much should they sell the poinsettias for to earn the most money? Well, I see this word most here, and that's supposed to be our maximum. Okay, well, we found our maximum back in part B. Okay, how much should they sell them for? Remember, P is the $1 price increases, and P in the max is 5. So that means I'm supposed to be increasing the price by $5. Well, what did they start out at? They started out at $5 a piece, and I want to increase them by $5. So if I sell them for 10, that will be the maximum. All right, one more here, number 3. A football is kicked up from the ground with initial upward velocity of 90 feet per second. The equation gives the height of the ball after t seconds. At what height was the ball kicked? That's the starting point, folks. And remember, starting point is always the y-intercept. So we are going to plug in 0. Now this time it's not for x, it's for t, because we don't have x's here. If you plug in 0, you'll get 0. That means this ball was kicked from 0 feet off the ground, meaning the ball is on the ground. What is the height of the ball after 1 second? Well, they tell you back up in here in the problem that t is supposed to be for seconds. So if I have 1 second, I'm going to plug that 1 in for those t's, and that'll tell me that after 1 second, the ball is 74 foot off the ground. How high will the ball travel? That's just another way of saying how tall, how high will it go? What's the maximum? So that means I need to find my vertex. Negative b over 2 times a, and that should give you this kind of funky looking decimal that you're going to have to plug in. And again, when you plug it in, you're going to get another decimal. If you want, you could change that decimal into a fraction, and that's how high the football will go off the ground. And then it says, how long will the ball be in the air? Well, the football is traveling like this, folks. It's reaching its maximum. We already found that in part C. And remember, the vertex is right in the middle of a parabola. So from part C, they're telling me it takes that long to get to the maximum. Well, if that's right in the middle of my vertex, I basically just need to double that because it takes 2.8125 seconds to get to here. And then it will also take the same amount of time to get down here because my parabola is symmetrical. So if I double that number, I get approximately 5.6 seconds that football is actually in the air from the time you kick it to the time it lands on the ground. All right, folks, that is your notes for today. Your homework for this section is this. Notice at number 58, you're only going to do B and C. I caution you, please read the directions so you know what they are asking you for. All right, I hope you have a good day, and I will see you tomorrow.